Hey, natural science student, if you're watching this video, it's because you missed the class day in which we built the graph for the change of state lab. And building this graph is a critical exercise for us to go through in order to be able to know what is happening with energy movement and how energy changes matter in our change of state lab. That's the whole objective. That's our big picture question for this section. How does energy change matter? And in order to be able to do that, we measured the temperature of ice as it changed into water and water as it changed into steam. And so I want to take you through the process for making the graph today, because if you try to answer the questions without first representing the data in graphical form, the questions aren't going to make any sense for you. So this is now a two-step process for you, and you have to do the first step before you get to the second step. So on the screen in front of you, you'll see an example of some data that might have been present for a group within class. Your data may not look exactly like this, but it should look similar to it in that there is a trend that is happening in these data. We have not a very big increase in temperature at the beginning. We have an increase of temperature that continues throughout most of the experiment, and then the temperature levels off at the end. And it is that nature of how these numbers are changing on the graph that we want to make sure that we are thinking about when answering the question. So how would you go about doing this? Well, here's an example of some graph paper that looks just like the graph paper that you have on your lab. Now what I'm going to do here is I'm going to put some words up top here, and I'm going to choose a font size that is appropriate for this. I'm going to have 4 words up here that you can use to construct a title. And what I'm going to ask you to do here is I'm going to ask you to pause the video, make a title with these words, and then unpause the video and continue. So the 4 words that we need for this are the material that we worked with, ice. We need what we measured in the experiment, temperature. We need what we kept track of in the experiment that did not respond to what we were doing, time. We couldn't control how time works in the experiment, but we still kept track of it. And then we need the word change, because that was what we were paying attention to in this experiment. How do these things change? And so these 4 words you're going to use as part of building a title. And you're going to need some more words so that this can read like a sentence. Ice temperature time change is not a title. It doesn't make any sense. What you need to do is add words to this so that it does make sense. So what I'd encourage you to do is pause the video, write your title at the top of your graph, and then resume the video once you have written your title. Okay, so hopefully you've had an opportunity to write a title. I'm going to go ahead and write a title using these 4 words so that we can sort of compare it to your own. So my title is going to be The Change in the Temperature of Ice Over Time. Okay, and your title might be different than this, but so long as your title says the same thing that my title says, that's okay. Now we're going to make the graph, and in order to be able to do this, we have to consider what sort of variables we have here. On the y-axis of a graph, we're going to put a responding variable, because it is what we measured that responds to our experimental situation. And on the x-axis of the graph, we're going to put our manipulated variable. In this case, manipulated means something that we kept track of, but that we couldn't control. We can't decide how long a minute is. We can't decide how long an hour is, but we can keep track of it. And so our manipulated variable, I'm going to put it down here, is, and I need an appropriate font size for this, our manipulated variable is time. We kept track of it, and we kept track of it in minutes. I'm going to go ahead and shrink this down a little bit more so that it can fit here on our graph. So you're going to want to write time in minutes under your x-axis. And then we had our responding variable, temperature in degrees Celsius. And I will fix my formatting here after I get everything down. Temperature in degrees Celsius, and I'm going to make this smaller so that it can fit. You're going to write this sideways on your graph, so I'm going to rotate this so we see that it is sideways, and then I'm going to move it over here. So we've labeled our y-axis, temperature in degrees Celsius. Now we need axes numbers. The purpose of a graph is to try to display the information that you gathered to make it easier for someone to understand what happened in the experiment. So in order for that to happen, we want to make sure that our graph fills the majority of the space that we can possibly make it fill. And so what I'm going to do here is I'm going to choose time in minutes here that's going to match up with how long our experiment was. If I switch back over here, here's our data table. Our experiment went from 0 minutes up to 20 minutes. Some groups might have had it go a little longer or a little shorter than that, but we want to try to get the times of the graph to spread out across the entire x-axis. So I think what works pretty well here, my apologies for the bell, is if we were to start with 0 and then every space becomes a number. So 1, 2, you can label this along your graph. I'm just going to go down here and label all of our minutes. 8, 9. My experiment went to 20, but I'm going to go ahead and label this all the way out. Now, you can see that I'm kind of running out of space here because I need 2 digits for these larger numbers. That's okay, just as long as you know what's on what line. That's what matters. 20, 21, 22. We'll get all the way out here to 25 in case you went that far. Okay, so there's my times on the x-axis. I also need to label temperatures on the y-axis. Most groups' temperatures went from somewhere around 0 to somewhere around 100, although you can see in these data here that we have a 101, so we want to pick a scale for this graph that will suit our needs. I want you to pause the video and think about what could you make each line so that we can include all of our numbers between 0 and 100 in a way that it will spread it across the entire graph. So go ahead and pause the video and make a decision. Okay, welcome back. So what I'm going to go ahead and do here is I am going to rotate this so that it is going up sideways on the graph. And I'm going to reposition, oh, I lost it. Bear with me, folks. You know what, maybe I'll start typing and we'll go from there. So we're going to start our time at 0. I'm going to resize this so that I can get an appropriate size. I'm going to move it into a good starting position, and then I'm going to rotate this so that I can get my numbers going in the way that I want them to go. Okay, so we're going to start with 0, and then I've found that if you label every 5, and let me straighten this out so that the numbers are actually going straight. I'll get it. Bear with me. That's a little bit better. There we go. Okay, 5, 10, 15, 20, and you can just write these directly on your paper. 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and I still need to snag 105 here for some of those points that are going to be outside of it, okay? So there we go. We have our graph all labeled. I'm going to try to shrink this down a little bit so it's a little easier to see, and now I'm going to transfer my points over from my data, and I'm going to actually try to go to a split screen format here, I think, dual page display so that we can see them at the same time, okay? So here's my data over here on the left, and then we have the actual chart over here on the right, and what I've done here is that I've produced infinitely clonable points that we can move around here and place on our graph. So if you look over here at time 0, my temperature was 0, so I'm going to find time 0 and mark it off as 0 degrees. There's my first point. Time 1, my temperature jumps up to 1, so I'm going to go to time 1 right here, and I'm going between 0 and 5. 1, I think, is about right here. Okay? And then minute 2 is at 0. There we go. Okay, 0 degrees Celsius for minute 2. Minute 3, I'm basically just going over one line at a time, marking down what the temperature is at each minute. On minute 3, our temperature is 2 degrees. So at minute 3, approximately 2 is right there. Minute 4, I'm back down to 0. Remember, in any scientific experiment, we are recording what we see, not what we think should happen. Minute 5 is also a 0. Minute 6, it jumps up to 13. So I'm going to go where minute 6 is. here's 5, here's 10, here's 15. So in between those is minute 13. Minute 7, we are at 22. So I'm going to grab another point. Here's minute 7. Here's 20, slightly above that, 22. Minute 8, 39. Now, one thing that I should have mentioned a little bit earlier is that you should be recording the times and temperatures for your data. This is just an example, okay? Minute 9 is at 51. Minute 9, 51. So hopefully that gives you an idea of what the process is for making your graph. You should make your graph all the way up to however many minutes your experiment ran and what your total, where your points need to go on your graph. What I'm going to do just real quick here is I'm going to finish this graph. What you might want to do is pause the video and then after you're done making your graph, continue the video so that you can look over here and see what my completed graph looks like and compare it to your completed graph, because we want to make sure that we see both what the differences and the similarities are between each of our respective graphs. You're going to notice that your points are not going to be in the same position as my points, and that's okay. But there are going to be some similarities between my graph and your graph. So go ahead and pause the video and complete your graph and come back here and we'll do a quick little discussion of what these things look like. Okay, so hopefully you got a chance to pause the video. Here's my finished graph here. Even if your graph doesn't look exactly like my graph, notice how there is a flat part at the beginning of the graph then rises, and there's a flat part at the end. That's a big part of what you are going to be focusing on when you think about what this graph means in the conclusion questions. There is another video that you can watch if you need some more information on the conclusion questions. And so now that you have a completed graph, you're ready to think about what this means and what this tells us about energy. Thanks for watching.